Eric Burgess here. Find the mean, variance, and standard deviation. So we're given a probability distribution, a probability table, and we're told, hey, find these things. So let's go ahead, write out the various formulas that we're going to need, right? So the mean is equal to, now just a friendly reminder, the mean is equal to the expected value, sometimes denoted by just a capital E. And the mean is equal to each probability times each x summed together. So the way we would write this is we'd write the summation and then the probability of each x value times each x, and that's going to give us the mean. The variance is the sigma with the square, is going to again be, it's going to be just like this formula, only now we're going to square every x value. And we're going to take the mean squared off at the end. I'm not going to derive the formula here, we're just going to kind of use it. So we're going to have the summation of the probability of x times x squared, and then this whole thing minus the mean squared. And then of course, if we want to get just regular old sigma, we would simply take the square root of the variance. And these are the three formulas that we need. So using these, we're going to go ahead and find these things. So the mean is going to be each x value times each probability added together. So the first one, if we were to write this out longhand, it would be 0 times 0.4 plus 1 times 0.2 plus 2 times 0.2, right? 2 times 0.2 is right here, 1 times 0.2 is right here, 0 times 0.4 is right here. We're just multiplying them and adding them together. 3 times 0.1, I don't know why I want to say 0 so bad, plus 4 times 0.1, whatever this is equal to. And keep in mind, all we're doing is we're just doing this thing in the middle here many times, right? We just did it for the first pair, that first p of x times x, and then the next pair, and then the next pair. And then the sigma says we add it each time we do it. So that's how you interpret a formula like this. We're going to get out a value. So let's go ahead and do this. So we're going to get 0 times 0.4 is 0, so we don't need to put that one in. 1 times 0.2 is 0.2 plus 2 times 0.2 plus 3 times 0.1 is 0.3 plus 0.4, because 4 times 0.1 is 0.4. It'll do the multiplication first, so we don't need to worry about order operations here. It'll all happen in the right order. We do it, we get 1.3 as our mean. All right, now to do the variance. So the variance, we can really rewrite it just by modifying this one up here. So I'm going to go ahead and do it in red. You could rewrite it as an entirely separate thing, totally up to you. But you could see here, these look pretty similar. All we're really doing is adding this square to every x, and then we're subtracting the mean off squared at the end. So here's our mean. So we got that right there. So all we need to do is put squares on all the x values, like so. And we just need to subtract off 1.3 squared. That'll give us the variance. So let's go ahead and do that. So 0 times anything is just going to be 0, so that's fine. 1 squared is 1 times 0.2 is 0.2 plus 4, right? 2 squared is 4 times 0.2 plus 3 squared is 9. You could always type in 3 squared if you don't remember, times 0.1, and 4 squared is 16. So we're going to do plus. Because keep in mind, we're doing this thing over and over and over, and the sigma says every time we do this, we add the result. So we're going to do 16 times 0.1. And then at the very end, we take off the mean, which was 1.3 squared. And that's part of the formula here, so that's why the square shows up. And what do we get? We get out 1.81. So we're going to go ahead and write that down, 1.81. And if we take the square root of this answer, we should get the standard deviation. So we're going to go ahead and take the square root of our result. You could type this, or you could use the answer key, which is what I tend to use. So answer, will just place what we had last. And so we're going to go ahead and do that. And we get 1.35. Rounding to 2 decimal places sort of randomly. So is there a way to check this? Yes, there is. Now, this calculator won't give us standard deviation, but it will give us the variance in the mean. And if we got this right, then we got this right. So let's go ahead and do this. So first you need to put them in a list. So we're going to go to Stat. We're going to go into Edit, and then the first option. And if you have stuff in your list, go ahead and clear it. So we're going to clear this one. You just push up, hit clear, push down. Push up, hit clear, push down. Great. So first we want our x values. So we have the numbers 0 through 4. So 0, 1, 2, 3, 4. And then we have our probabilities, which is 0.4, 0.2, 0.2, 0.1, 0.1. Okay, so we just check 0 through 4. That's fine. 4, 0.2, 0.2, 0.1, 0.1. Perfect. Now we're going to hit statistic, or the stat key, and we're going to go over to calculate one var stats. So we're going to choose this one, and make sure your list for your x values is list 1, and your frequency list is list 2. And you can change the list. They're in blue here. So just hit the blue key and then hit the thing you want. So if I wanted to change this to like list 3, I would hit the blue key and hit list 3, like so. But I want it to be list 2. Now we're going to hit calculate, and we get our mean. So you could see here our mean, x bar, is 1.3, exactly what we got. And the standard deviation, oh, I think this one doesn't give you the variance. It does give you standard deviation though. So we get 1.345 la la la, which is this, which we got from this. So that sort of verifies each one. So there's a way to quickly check with the calculator. There's some additional stats here too that may or may not be of use to you depending on the problem. If you have any questions about this, feel free to let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.